Let's start with number 1. Alright, so we have this triangle, and we're given that I'm going to call this side A, that's 5. Call this side B, that's 4. It says find side C. Tells us this angle here. If it has that little square, that means it's a 90-degree angle. And then this is angle B, because it's across from side B. And then this is angle A. This is across from side A. So the first thing I would do is probably find side C by using the Pythagorean theorem. So C squared equals A squared plus B squared. So C squared equals 5 squared is 25, and then 4 squared is 16. So C squared equals 41. So take square root of both sides. So C equals, and you'd want to do that in a calculator. Directions say to round to 2 decimal places if needed. So it'd be 6.40 or 6.4. Alright, then I would solve for A and B. So these two angles here. I'd really probably just solve for one and then use the fact that the 3 angles add up to be 180 to get the other. And I would use the values that are given. So let's say that I want to solve for angle A. Then the opposite side is known and the adjacent side is known. So opposite over adjacent is tangent. So the tangent of A equals opposite over adjacent. And this is where you need to use the inverse trig function. So you'll say the inverse tangent of 5 over 4. So you need to make sure if all this is in degrees, then your calculator has to be in degrees. Alright, this one here is already. So let's say 5 divided by 4 equals, and then I'm going to do inverse tangent. If I round that to 2 places, that's 51.34. So angle A is about 51.34 degrees. I could do another tangent and then do 4 over 5, but again, you could use the fact that the 3 angles add up to be 180. That's the easiest way. So angle B would be 180 degrees minus 90 degrees, because this is 90 here, and then minus 51.34 degrees. So that's just going to be 180 minus 90 is 90, minus 51.34 gives me 38.66. So angle B is 38.66 degrees. Alright, and that answer's down there. That's B on this practice test. Number 2, the sine of the inverse sine of negative 0.5. That's right, because this number right here, the inverse is on the inside, and since this number right here is greater than negative 1 and less than, greater than or equal to negative 1 and less than or equal to 1, the answer is just what's inside there. So it's negative 0.5. Alright, problem number 3 says the sine of theta is greater than 0 and the cosine of theta is less than 0. in which quadrant does the angle lie? So I would think about the Salty Sea chart here. This tells you where all the angles are positive. So sine is greater than 0 or positive here and here. Cosine is less than 0 or cosine is negative here and here. Where does it overlap? Quadrant 2. So quadrant 2. That's the answer. Number 4, the tangent of 75 degrees minus the cosine of 15 degrees over the cosine of 75 degrees. So we have to use the complementary angle theorem here first and I would change cosine of 15 degrees into what it's equal to with its cofunction. Not complementary angle theorem. I think it's called I think that's what it's called, but you use cofunctions, right? So the cofunction for cosine is sine. And the rule is, if the two angle measures add up to be 90 degrees, then they're equal. So the cosine of 15 is the same thing as the sine of 75. So the reason that I wanted to do that is so now I have the sine of 75 degrees over the cosine of 75 degrees. So I have the tangent of 75 degrees minus the tangent of 75 degrees. So that has to be something subtracted from itself. So that's 0. All right. Number 5. The inverse tangent of the tangent of 4 pi over 5. All right, so the rule is that inverse tangent, since the inverse is on the outside, okay, where is inverse tangent defined? It's defined from negative pi over 2 to pi over 2. So if this angle measure, 4 pi over 5, is in one of these two quadrants, then you just take the answer. However, 4 pi over 5 is not. And the way that I know that is because this is 1/2 pi, this is 1 pi, well that's 4/5 pi. And 4/5 is greater than 1/2, but it's less than 1. So what I have to do is, I know that it's in the second quadrant because it's 4 pi over 5, but I have to change it into either the first or fourth quadrant, written as a negative angle measure, depending on whether tangent is positive or negative in the second quadrant. Well, tangent is negative in the second quadrant. So you need to change it into the angle measure. Which quadrant is tangent negative in, the first or the fourth? The fourth, right? None of the trig functions are negative in the first quadrant. So you want to change it into its multiple from the fourth. I'm gonna get it right eventually. From the fourth quadrant, written as a negative angle measure. All right. There's a trick to that. So the trick is to figure out, and this only works for inverse sine and inverse tangent. If you figure out the angle from the first quadrant, that's called the reference angle, then you can just make it negative, and that automatically puts it in the fourth quadrant. Okay. So do you remember the reference angle chart? The reference angle chart, any angle measure from the first quadrant is called the reference angle. In the second quadrant, that's pi minus theta. In the third quadrant, it's pi plus theta. And in the fourth quadrant, it's 2 pi minus theta. So if I want to change it over to I want to figure out what the reference angle is, I say pi minus theta equals 4 pi over 5. Pi minus theta equals 4 pi over 5. If I solve for theta, then this is going to give me the reference angle for that angle, the angle measure from the first quadrant. So I'd subtract pi from both sides. Now here's where some students get stumped. You got to get a common denominator because this is 4/5 and this is -1. So 5 is my common denominator. -1 pi is the same as -5 pi over 5. All right? So 4 pi over 5 minus 5 pi over 5 is -pi over 5. That's not my answer though because I have negative theta equals that. So divide both sides by -1 and you get theta equals pi over 5. Now, that's the angle measure from the first quadrant. That's the reference angle. So if you want to put it in the fourth quadrant written as a negative angle measure, you just make it negative. Remember, that's the trick for inverse sine and inverse tangent. So the answer has to be -pi over 5. Is it down there? It's down there. -pi over 5. All right. Again, the reason why we do that is because 4 pi over 5 is in the second quadrant. Inverse tangent is defined between -pi over 2 and pi over 2. So you have to change this over to the quadrant where tangent would be the same plus or minus sign. And that's going to be in the fourth quadrant. That's also where tangent is negative. So to change it down there, you have to figure out the reference angle. And then the trick is to just put a negative in front of it. Now, another way you could do it is to say 2 pi minus pi over 5. And that would give you 9 pi over 5. But you'd have to subtract 2 pi from that and bring it around one complete revolution. That way sometimes confuses students, so I usually don't teach it that way. All right, anyway, so we figured that one out. Let's do number 6. So we're going to write this product, the sine of 6 theta times the sine of 4 theta, as a sum. All right, so that means that we need to go to our formula sheet, or we need to know those formulas. That would be impressive if you knew all these product to sum and sum to product formulas. So we're looking for the product that is sine times sine. So we consider this first angle measure, that's going to be our alpha. Our second angle measure, that's going to be our beta. And we look at sine of alpha times sine of beta, and we get 1/2 times the cosine of alpha minus beta minus the cosine of alpha plus beta. All right, so our answer would be 1/2 times the cosine of, we got 6 theta minus 4 theta. So what's 6 minus 4? 2 theta. Then we have minus cosine of 6 theta plus 4 theta. That's going to be 10 theta. All right, and so that's the answer that we look for. You may see these angle measures put in parentheses like that. That just kind of groups them together a little bit. All right, the next problem says find the area of the triangle. So it depends on the information that's given. We may use the sine formula. There's a formula using sine if you know 2 sides and the included angle, which is basically 1/2 base times height. Or if you know all the sides, that's where you use that Heron's formula. Well, in this problem, we know 2 sides and the included angle measure. And so the formula is 1/2 times the 2 sides. I'm just going to call them A and B. It doesn't matter. But I'm going to call them A and B, and then it would be times the sine of angle C. So think of one of them as A, one of them as B, and this is angle C. When you know those 3 in a row, you know 2 sides and the included angle measure, use this formula. I'm not sure if that's on your formula sheet. but I know that when we went over it, I told you could write it down. Because it's the same thing as 1/2 times base times height. B times sine of C would give you the height. So that's 1/2 times 3 times 10 times the sine of 10 degrees. Alright, so again, we've got to use a calculator. I don't know what the sine of 10 degrees is. I bet it's a small number, but I still don't know what it is. So that's going to be 30 times 1/2 is 15. Put that in first. Times the sine of 10 degrees here, I have to say 10 sine. I think in the calculators you have, you may have to push the sine first. Alright. But I should get, and this says to round to 2 decimal places, my area should be 2.60. 2.60, and it's square units. There was no inches or feet. If we would have had that, it'd be like square inches, square feet, but there's no units written down, so I'll just leave it like that. Area is always square units. Alright, the next problem has the same directions. However, it's not a side angle side triangle. It's a side 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 triangle. So we're going to use Heron's formula. Now Heron's formula, the first thing you have to do is take half of the perimeter. So it's half of the sum of the sides. Alright, so that's 28, 38, 40. Half of 40 is 20. And then the formula is the square root of S, that was half the perimeter. So that's the square root of 20 times S minus A, so S minus one of the sides, times S minus B, another side, times S minus C, another side. Okay? So what's that going to give me? Let's see, the square root of 20 times 20 minus 14 times 20 minus 14 times 20 minus 12. Or the square root of 20 times 6 times 6 times 8. So it's the square root of a big number. Relatively big, I guess. 20 times 6 times 6 times 8. 5,760. So the square root of that. Okay, and we want to round that to 2 places. So 75.89. So it's about 75.89. A common mistake is to forget to take the square root at the end. So let's make sure we don't do that. And that's another one of those formulas I said that you can write down. Heron's formula. Alright, number 9. Solve the trig equation. So if you're going into calculus, you got to be able to solve trig equations. If not, congratulations. You need to know it for the final. And then you don't need to know it anymore, I guess. So what we want to do is solve for theta. So we need to get cosine of theta by itself. So think about the cosine of theta like it was just an x and you were solving for x. So you'd subtract 3 from both sides. Divide both sides by 2. So I have cosine theta equals negative 1/2. Now this is a problem where either you use your knowledge of the unit circle or you use your unit circle and you figure out which x values or negative 1/2, or for what angle measure. And so that's going to be 2 pi over 3 and 4 pi over 3. Another way to do that is using the reference angle chart. The way that you would use the reference angle chart is you would say, okay, the cosine of what is positive 1/2, and that's pi over 3. Then if we say pi minus pi over 3, we get 2 pi over 3. If we say pi plus pi over 3, we get 4 pi over 3. Either way, you can get the same answer, same two answers. All right, problem number 10. 4 sine squared theta equals 1. So I want to solve for theta. So again, think about it. What would you do if this was 4x squared equals 1? Well, the first thing you'd have to do is divide both sides by 4. So I get sine squared theta equals 1/4. Take the square root of both sides. Remember, when you take the square root of both sides, you have to put a plus or minus with the number side. So you get sine theta equals plus or minus. Now, how do I take the square root of a fraction? That's the square root of the numerator over the square root of the denominator. All right, so that gives me plus or minus 1/2. Now, I need to know all of the places where sine is positive 1/2 and where sine is negative 1/2. So that's the answers from all 4 quadrants. And remember, sine is the y-coordinate on the unit circle. So if you look there in the first quadrant, you'll see a y of what? Pi over 6. Or 4 pi over 6, you'll see a y of positive 1/2. If you want the answer from the second quadrant, either you use your unit circle or you remember it's pi minus pi over 6. That's 5 pi over 6. The third quadrant, it's pi plus pi over 6. That's 7 pi over 6. And the fourth quadrant, remember it's 2 pi minus the reference angle, so 2 pi minus pi over 6. That's 11 pi over 6. So that's your 4 answers. Alright, number 11 skips back and to a sum or difference. So, you know, all these problems are skipping around, all the stuff we've covered all semester. Cosine of 9 theta minus cosine of 3 theta. Alright, so it says express the sum or difference as a product. So look at your formula sheet where you have sum to product formulas, and we're looking for cosine of alpha minus cosine of beta. So 9 theta is our alpha, 3 theta is our beta. And our formula is negative 2 times the sine of alpha plus beta over 2 times the sine of alpha minus beta over 2. So that's going to be negative 2 times the sine of, need to add 9 theta and 3 theta, you get 12 theta over 2 times the sine of, what's 9 theta minus 3 theta? 6 theta over 2. Alright, so I have negative 2 times the sine of 12 theta divided by 2 is 6 theta times the sine of 6 theta divided by 2 is 3 theta. Now remember, since you're multiplying these two signs together, you could have them reversed. You could have the sine of 3 theta first and the sine of 6 theta second. So either way should give you the same answer. On the answer sheet I'm looking at, it's written like we have it written. So negative 2 sine 6 theta times sine 3 theta. All right. Problem number 12. the tangent of the inverse cosine of negative 1/2. All right, got to know a couple of things. You got to know where inverse cosine is defined, right? Got to know where inverse cosine is defined to work this out. Now, technically, there's two ways to work this out. I'm sure there's more than two ways. There's two ways that we've covered. Since the inverse is on the inside and negative 1/2 is a common angle measure, we could probably work out the inside, then take the tangent of that and get the answer easily. But the way that I always teach you how to work these problems when the inverse is on the inside is to use x, y, and r. And that's because sometimes this won't be a common number. All right? It's just that this is a common value for cosine, makes it where you can work it the other way. Now, remember, inverse cosine is defined from 0 to pi. And if you're taking the inverse cosine of something that's negative, the answer then has to come from the second quadrant because cosine is negative there. All right, so what you do is you figure out the one from the first quadrant and then you say pi minus that angle. And that'll give you the one from the second quadrant. There is no trick like inverse sine and inverse tangent. Inverse cosine, you do have to do it the longer way. So the cosine of what is positive 1/2? Well, we all know that's pi over 3. So if I want to get the angle from the second quadrant, I say what? Pi minus pi over 3. So by the way, I'm showing you two ways to work this problem. I'm going to show you the way you can always work it and the way that works if you have common values. So if you have common values, this is how you would work it. So this would give us 2 pi over 3. So if you take the tangent of 2 pi over 3, so what is that? That's going to be negative, and then the sine of 2 pi over 3 is square root of 3 over 2. So square root of 3 over 2 divided by 1/2 is what? Negative square root of 3. Is that right? All right, so that's the way you can do it if you have a common value in here. If you don't have a common value, here's the way that I showed you also, was you say cosine of theta must be equal to negative 1/2. We know that we're in the second quadrant, so y's are positive and x's are negative. Well, remember, cosine is x over r. X's are negative. Well, that's good. It works out. That's what it should be. So x is negative 1, and that would make r a positive 2. R always has to be positive because it's a radius. So to take the tangent, what do I need? Tangent is y over x. So I need to know what my y is. So the way that I get that is by using x squared plus y squared equals r squared. It's basically the Pythagorean theorem, but for circles. All right, so negative 1 squared plus y squared equals 2 squared. 1 plus y squared equals 4. Subtract 1, subtract 1. Y squared equals 3. Take the square root of both sides. Y equals plus or minus the square root of 3. However, we're in the second quadrant where y is what? Positive. So y is equal to a positive square root of 3. Alright, so my answer is going to be positive square root of 3 divided by negative 1. So it's negative square root of 3. So either way you work the problem out, you get the same answer. All right, number 13. The cosine of the inverse sine of 1/2. This is another one of those problems that can be worked out both ways. I'm just going to work this one out one way. I'm going to work it out using x, y, and r. All right, so just like I did, that was the second way that I showed you how to work number 12. So what I do first is I say sine of what is positive 1/2. So where is inverse sine defined? You know that it's defined between negative pi over 2 and pi over 2. Well, this is a positive, so I want the answer from the first quadrant. So theta is equal to, I'm not going to tell you. If I tell you, then I'm working it the other way. All right, let's see though. Let's figure it out. Sine is 1/2, so sine is y over r. So what's y equal to? 1. What's r equal to? 2. We know that we're in the first quadrant, so all x's and y's are positive. So to find the cosine of theta, we need x over r. So I don't have x, so I use x squared plus y squared equals r squared. Alright, so x squared plus 1 equals 4. Subtract 1, subtract 1. So x squared equals 3. So x equals plus or minus the square root of 3. But I'm in the first quadrant, so it's x equals a positive square root of 3. Because I'm in the first quadrant. That's where this inverse was defined. So that's square root of 3 over, what was the radius? 2. So if you're wondering the other way, how would you get the answer? All you do is you solve for theta here and you would get pi over 6. And then you take the cosine of pi over 6, you get the square root of 3 over 2. But again, that's not always going to work, especially if those numbers on the inside, if these numbers on the inside aren't common values, don't give you common angle measures. All right, number 14. The inverse sine of square root of 2 over 2. So inverse sine is defined between negative pi over 2 and pi over 2. Right? So this is the inverse sine of a positive. So we want the answer from the first quadrant. So tell me, the sine of what angle measure equals square root of 2 over 2? So you just need to look at the y coordinate in the first quadrant, and you get theta, where the answer is what? Pi over 4. Now, if this would have been the inverse sine of negative square root of 2 over 2, then you would have got negative pi over 4. All right, number 15. Graph y equals 3 tangent 2x. So remember, the main thing with tangent is, where is it going to cross the x-axis, or where is it going to be equal to 0? So that's the same thing. It's going to cross, or where will it equal 0? And then the other thing that's important is, where will it be undefined? Because that's going to be where you're going to have your vertical asymptotes. Well, I told you to remember, the easiest way to do this is to remember that the tangent of 0 is always 0. So it's always going to cross at x equals 0. Because if I plug in a 0 right here, it doesn't matter what number's in front of it, you're still taking the tangent of 0. And that's always 0. So you're always going to cross there. Yeah, cotangent's the other way. It's always going to have a vertical asymptote at 0. So the easiest way to graph this is going to be, we know, I'm about to put some points out here, so ours may not be exactly to scale, but we'll match it up with a graph if this is a multiple choice problem. So we know that we're going to cross at 0, so we have to cross here. Now we need to use the period. Now how do I find the period for tangent? You say pi divided by omega. All right, for tangent and cotangent, it's pi divided by whatever's in front of the x. So the period is pi over 2. So it's going to cross at every, if it crosses at 0, then you add pi over 2 to that. It's going to cross again at pi over 2. Add pi over 2 to that. Pi over 2 plus pi over 2 is pi. Right? 1/2 plus 1/2 is 1. Now directly in between any two places that it crosses, so we know it's going to cross here and it's going to cross here. The midpoint between any two places that it's going to cross, so if you add those two x's together and divide by 2, at pi over 4, you're going to have a vertical asymptote. And if you add these two x's together, the next two x's together and divide by 2, at 3 pi over 4, you're going to have a vertical asymptote. Remember, tangent goes up and to the right and down and to the left. Up and to the right and down to the left. Up and to the right and down to the left. You can probably pick the graph out by just looking at the places where it crosses. So it should cross at 0, pi over 2, and pi. If it crosses at more places than that and you're looking at multiple choices, then you know it's wrong. If it doesn't cross it at least, at those 3 places, then you know it's wrong. So on our choices, that has to be what? Has to be B. All right, number 16. Says to graph y equals 2 cosecant of 1/4 x. Now, there's no phase shift still, so that's good. But to graph cosecant, you first have to graph its reciprocal sine. Okay? So, the amplitude does matter with this graph. So, the amplitude is the absolute value of 2, or 2. The period, if you remember, for sine, cosine, secant, and cosecant, is 2 pi divided by omega. So it's 2 pi divided by 1/4, which is 8 pi. So that means I'm going to be able to draw the entire graph between 0 and 8 pi. Alright, so I'll come up with my 4 subintervals that are going to give me my significant points. How do I get the value that I'm going to add to 0 to get the next significant point? You do the same thing every time. You always take the period, and divide by 4. That's because there's 4 subintervals and you want them to be evenly spaced out. So I'm going to add 2 pi to the previous significant point to get the next significant point. So 2 pi, and then put another 2 pi here, so the next interval is going to be from 2 pi to add 2 pi to that again, 4 pi, we'll put down 4 pi, add 2 pi to that again, 6 pi. Now here's where we can check ourselves to make sure that we did everything right. Add 2 pi to that again, 8 pi.
You started with 0 because it's the sine.
I started at 0 because there's no phase shift. If we would have had minus something or plus something, that's when we have to start at a different place.
Okay.
Alright, so I'm going to sketch this. I'm going to label it, and then we can change it over to cosecant. Alright, So I'm going to space it out a little bit. We know that we're going to draw one complete period where this is going to be 2 pi, 4 pi, 6 pi, and 8 pi. And of course this is 0. So we're going to start at 0 and we have to draw the basic sine curve. So sine starts at 0, it starts at the axis. At the next significant point we have a high point. Well, our high point was 2. So that's going to be 2, and this down here will be -2. Then at the next significant point we cross. At the next significant point we have a low point, and at the last significant point we cross. So up, down, up. Alright, so that's what sine looks like. But what about cosecant? Because that's what we originally wanted to graph. So we have to come up here, and every place that you cross cosecant is going to have a vertical asymptote. At every high point you're going to have a U-shaped graph opening upward. And at every low point you're going to have a U-shaped graph opening downward. So if you're looking at multiple choices for that, if this isn't one that you have to work out, you just want to make sure that you have a U-shape opening upward at 2 pi and a U-shape opening downward at 6 pi. So that would be the main thing I would look for. And if you have any U-shaped graph like on the axis, you know it's wrong, because we have a vertical asymptote on the axis. So to me, that looks like, which one? B. Okay. All right. Number 17. Y equals cosine 3x. Find the period. I'd be highly disappointed if you miss this one. To find the period, some of you may miss it on purpose now. It's 2 pi divided by omega. So it's 2 pi divided by 3. 2 pi over 3. Number 18 is equally as easy. It says, find the amplitude. Remember, amplitude has to do with the number in the front. So the amplitude here is going to be the absolute value of -3. So what's the absolute value of -3? 3. Alright. Ooh, we're getting into a good problem now. Number 19 says theta is between 0 and 2 pi, and it tells us the sine of theta equals 1/4. Also tells us that theta is greater than 0 and less than pi over 2. That just tells us which quadrant it's in. Find the sine of theta over 2. So we're trying to find the half angle. This tells us that theta is between 0 and pi over 2. So theta over 2 has to be between 0 and pi over 4. That's important because that tells us whether we use a plus or minus with our formula. So this still tells us that theta is in the first quadrant though. So it's going to be a positive square root of 1 minus cosine of theta divided by 2. So I have sine of theta and I'm told we're in the first quadrant. We need to find cosine of theta. The way we do that is by using x, y, and r. So sine is 1/4, or y equals 1, r equals 4. We need to find cosine. Cosine is x over r. So I need to solve for x. Do that by using x squared plus y squared equals r squared. So x squared plus 1 squared equals 4 squared. Or x squared plus 1 equals 16. Or x squared equals 15. And you subtract 1 from both sides. So x equals plus or minus the square root of 15. Which quadrant are we in though? Theta's in the first quadrant, so it's a positive square root of 15. So cosine of theta then is going to be positive square root of 15 over what? 4, the radius. So that's what we have to use in our formula. Okay? So sine of theta over 2 is the square root of 1 minus square root of 15 over 4 all over 2. So what we want to do now is multiply the numerator and denominator under the radical times the same number so that you can get rid of the fraction and you can take the square root of the denominator. So it has to be multiples of 4. So what are our multiples of 4? 4, well, that would get rid of that, but that would give us a what in the denominator? That would give us an 8. So that won't work. What if I try 8? If you multiply both of these numbers times 8, that will get rid of the 4, and 2 times 8, the square root of 16 is a whole number. So that's how you do it. So multiply 8 times these two numbers. So you'll have the square root of 8. And then when you multiply it times this number, 8 divided by 4 is 2. 2 times the square root. So it's going to be minus 2 times the square root of 15 over the square root of 16. So, and we can take the square root of 16. That's why we made that. That's why we multiplied the numerator and denominator by 8. So that's our answer. It's only one of those up there. All right. Number 20. Find the sine of 2 theta. And it tells us that the cosine equals 7 over 25, and that theta is greater than 3 pi over 2, but less than 2 pi. So that tells us that theta is in which quadrant? The fourth, that's right. Because here's 3 pi over 2, and then when you go, if you keep going around, that's 0 or 2 pi. Now, what's the formula for the sine of 2 theta? It's 2 times the sine of theta times the cosine of theta. That's the formula for the sine of 2 theta. All right. So, I have what cosine of theta is equal to. Sorry, I didn't write my theta there. I have what cosine of theta is equal to. Well, what about sine of theta? I have to figure that out. So, cosine, again, is x over r. So, I'm in the fourth quadrant, so all y's are negative and all x's are positive. So, I need to solve for y so that I can solve for sine, because remember, sine of theta is y over r. So x squared plus y squared equals r squared, or 7 squared plus y squared equals 25 squared. So 49 plus y squared equals 625. I think that's 25 squared. Yeah. So y squared equals, gonna have to use a calculator, maybe not. 500 and, is that 76? I'm just guessing. I think I've done that before. So take the square root of both sides. Y equals what? Let's see. 5, 7, 6, square root 24. But since I'm in the fourth quadrant, the y is negative. So y equals negative 24. So that tells me that sine is going to be negative 24 over 25. Now we're going to take and we're going to plug in our answer for cosine and our answer for sine into our formula. So the sine of 2 theta equals 2 times, sine is negative 24 over 25, and cosine is 7 over 25. So let's see what that'll be. I know what the denominator will be. 25 times 25 is 625, but 2 times a negative 24 times a 7, negative 336. So it's negative 336 over 625. All right. Now, problem number 21. Sine of theta equals the square root of 5 over 3. Cosine of theta equals 2/3. Find secant of theta. The easiest way to do this is by using the reciprocal identity. So what's the reciprocal of secant? Cosine. So what's the reciprocal of cosine? Secant. So just take the answer for cosine and flip it. Take the reciprocal. 3/2. That's your answer. All right. 22. This says convert pi over 3 to degrees. So to convert to degrees, you multiply by 180 over pi, or you just plug in a 184 pi. So I get 180 divided by 3, so that's 60 degrees. Number 23, use the fact that the trig functions are periodic to find the exact value of the expression. That just means use the fact that you know that 360 degrees is 1 revolution to find the sine of 855 degrees. So if you have something bigger than 360 degrees, you just subtract 360. So that'll be the sine of 495 degrees. Well, that's still too big. So subtract 360 again. That's the sine of 135 degrees. So either use your unit circle or use your knowledge. I prefer you to use your knowledge. Okay, that's in the second quadrant, so it's going to be positive if it's sine, and it's the same as the sine of 45 degrees. So it's going to be what? Positive square root of 2 over 2. Again, that's because I know that the reference angle for 135 is 45. Or you just look for the y coordinate at 135 degrees. Alright, number 24. These seem to be getting easier and easier. The tangent of 2 pi. Well, the tangent of 2 pi is the same thing as the tangent of 0. We did that earlier when we were graphing. Remember what happened at 0? You crossed. So the tangent of 0 was 0. So the tangent of 2 pi is 0. Number 25. The sine of 0. So either use your unit circle or use the fact that you probably should know at this point that the sine of 0 is 0. Oh, stepping it up a notch for this next one. Solve the triangle. Alright, so this will help you with that last unit test as well. So yeah, this triangle got 30 degrees, and that's angle B. Don't know angle C. Angle A is 125 degrees. Side C we don't know. Side A we don't know. Side B we know is equal to 5. So it just says solve the triangle. Well, the first thing I would do is I would solve for angle C because that's the easiest thing to do. Right, we know these three have to add up to be 180 degrees. So C is going to equal 180 minus 30 minus 125. So what's that? Is that 25? Okay, so we know what C is equal to. Now, since you know a corresponding side and angle, I would use the law of sines. So we can say the sine of 30 degrees over 5 equals, and now we can solve for side C or side A. Can't solve for them both at the same time. Let's solve for side A. So we'll say equals the sine of 125 degrees over side A. Right, corresponding side and angle. You got to set up the proportion. This is law of sines. So cross multiply and divide. You have A times the sine of 30 degrees equals 5 times the sine of 125 degrees. Divide both sides by the sine of 30 degrees. And you plug that in the calculator. So you got to learn how to use your calculator. So 5 times, for mine I got to say 125 sine equals divided by, well, I know what the sine of 30 degrees is, but I'm going to punch it in anyway. Equals. If I round it to 2 places, then that's going to be 8.19. So side A is about 8.19. Now I can solve for side C. I'll start off with the same proportion. Sine of 30 degrees over 5 equals, now I'm going to solve for side C, knowing that angle C is 25 degrees, so that's a sine of 25 degrees over C. Cross multiply, set those equal. C times the sine of 30 degrees equals 5 times the sine of 25 degrees. Divide both sides by the sine of 30 degrees. And I get C is about and I got about 4.23. Alright, so I've solved for all of the unknowns in that triangle. The next problem says two sides and an angle are given. Determine whether the given information results in one triangle, two triangles, or no triangle at all. Solve all triangles that result. Alright, so this is number 27. We're given that angle B equals 88 degrees, side B equals 4, and side A equals 25. So remember, this is called the ambiguous case when you have one angle measure and two sides. Alright, it does not matter how you set your triangle up, just know that if you call this angle B, this has to be side B. If we were to call this angle A, this would have to be side A. If we call this angle C, that will have to be side C. So angles and sides must be across from each other. So this is 88 degrees. This side is 4, and this side is 25. So let's try to solve for angle A, since I know side A, using law of sines, because I have a side and angle that match up. So the sine of 88 degrees over 4 equals, now let's try to solve for A since we know side A. It's going to be the sine of A over 25. Let's cross multiply. So 25 times the sine of 88 degrees equals 4 times the sine of A. Divide both sides by 4. Alright, so this is where you use the inverse sign in the calculator. But you got to do all this stuff first. So 25 times 88 sine equals, divided by 4 equals, and now you do inverse sine. So second sine, domain error, invalid input. So that means no triangle. Alright, so 27 is the no triangle. Number 28. We're given a triangle. We're given that this is 35 degrees, this is 2, this is 8, this is side B, this is angle C, this is angle A. Do we have a matching corresponding or a corresponding side and angle that we know? No. So that means you cannot use the law of sines. That means that we have to use the law of cosines. Alright, so let's see. The easiest thing to do now is going to be, nothing's easy really, but finding for B. I guess finding the value for B. So use the formula B squared equals A squared plus C squared minus 2 what? AC times the cosine of B, and that's on your formula sheet. Alright, so B squared equals 2 squared plus 8 squared minus 2 times 2 times 8 times the cosine of 35 degrees. So that's 4 plus 64 minus 32 times the cosine of 35 degrees. Alright, you need to put all that together and take the square root of it, because B squared equals that. So 4 plus 64 minus, I'm going to have to say, I got to be tricky with this, minus, I'm going to put parentheses, 32 times 35 cosine equals. Okay, so that's what b squared equals. So take the square root of that and run that to two places. So b squared was whatever was up there first at 41.7871. So b is about 6.46. All right, now since we have to use the formula to get angle A and angle C, what I would do is write this out to about 5 or 6 digits, and then you can always round it later when you're looking for your final answer. So I'm going to put 4296. That's the next couple digits. So 4296. That's because I'm going to have to use that value in a formula. Okay? So now if I want to find, let's solve for A. I've already solved the law of cosines formulas for you for the angle measure. Do you remember what it was equal to? What would that be? So b squared plus c squared minus a squared over what? 2bc? 2bc. Alright, so let's plug in b. So you're going to have to put in that long decimal and square it. You need to, the reason why you need to carry it out is because we're putting a rounded value in a formula. That's a no-no. That's going to make you get a wrong answer. But if you carry it out far enough, then the percentage margin of error will be a lot smaller. So, and then c was 8, so plus 8 squared, and then minus a was 2, so minus 2 squared over 2 times that long decimal times c squared, and c, not c squared. C was what? 8. All right. So I'm gonna get rid of this, even though I could use that in my formula, just to see what I'll get. So 6.464.296 squared. This is plus 64 minus 4. Alright, so I'm going to write that down. 101.787122 7756. That's far enough. Over. There is a trick, I guess, since you're dividing by a product, you can divide by each one separately. So I guess I didn't have to write it down, but if you don't know that trick, you might want to write it down. I say a trick, it's just fact of life. Alright, so once you get this decimal, remember cosine of A equals this decimal. So you say second cosine, so you do inverse cosine. After you divide it all out, then you say second cosine, and it looks like you'll get 10.2 degrees. So if angle A is about 10.2 degrees, how can I find angle B? You say 180 minus 35 degrees minus 10.2 degrees. And what do you get? 134.8. All right, let's finish the last two problems. Problem number 29. It says solve the triangle. Yeah, a little technical difficulty with that triangle. There we go. 4 of 110 degrees 6, angle B, angle A. Alright, so we don't have a corresponding side and angle that we know. So that tells us that we're going to have to use the law of cosines. I would probably solve for, I think you have to solve for C first here. So we need to use the formula with C. So that's C squared equals A squared plus B squared minus 2AB cosine of C. So C squared equals, that's 4 squared plus 6 squared minus 2 times 4 times 6 times the cosine of 110 degrees. So C squared equals 16 plus 36 minus 48 times the cosine of 110 degrees. Alright, so that's going to be 52 minus 48 times the cosine of 110 degrees. And again, I'm solving for C squared, so whenever I do this in my calculator, I'm going to need to take the square root to get my answer for C. And I'm going to carry it out to several places because I have to use that answer in the formula to find one of these other angles. Alright, so 52 minus, and then I'm going to put in parentheses 48 times 110 cosine, close parentheses, equals. Alright, so I have to take the square root of that number, and that's going to give me C. And I'm going to carry it out again to about 5 or 6 places, so 8.271454, so 271454, that's enough. Alright, and so if you need to round that to a couple of places for your answer for side C, then you just round it 2 places, but we have to use this in another formula again. That's why I am taking it out so many places. So what I'd suggest doing is either solving for angle A or B, because then you can use the fact that the 3 angles add up to be 180 degrees to find the third angle. So I'll solve for A. So the cosine of A in your formula sheet, you have that equals A squared plus B squared minus C squared all over 2AB. Alright, so remember that's A there, that's B there, and we've already solved for C. Alright, so the cosine of angle A is equal to 4 squared plus 6 squared minus, I got this 8.271454 squared all over 2 times A is 4 times B is 6. Alright, so I'm going to do all this in the calculator. And then I'm going to have to use the inverse cosine function to find the answer. So that is 4 squared is 16 plus 6 squared is 36. I'm going to say minus, and now I have to square this thing here, so minus 8.271454 squared equals, alright, and then I'm going to divide this by 2 times 4 times 6, that's 8 times 6 or 48. And now I have to take the inverse cosine of this. So second cosine, and looks like this rounds pretty easily. to 110. Which is very strange because that's what I have here. So I may have actually used the wrong formula. Let's see. Of course I did. That was the formula for angle C. So I just showed that the cosine of C was equal to that. I'm glad it was, even though I didn't need to do that. Extra practice there. Yeah, so I need to write down the formula for the cosine of A. So the cosine of angle A is b squared plus c squared minus a squared over 2 times b times c. So that's actually what I want to do. So that's going to be 6 squared plus 8.271454 squared minus minus 4 squared all over 2 times 6 times, again, let's see, it's 2 times 6 times that long decimal. Now let's carefully plug this in the calculator. So it's going to be 6 squared, that's 36, plus, I'm about to punch this in, 8.271454, and I need to square that, so squared, and then I say minus, and then 4 squared is 16. So that's the numerator of this. Now, either write that down and then multiply the denominator and write that down and divide, or since you're multiplying all these numbers on the bottom, you can divide them each separately. So divided by 2 equals divided by 6 equals divided by 8.271454 equals, and then do second cosine, so inverse cosine. Alright, so angle A, and I'm just going to round this to 2 places. You know, if your answer is in, like, if it's 1/100th away, then it's probably because we plugged in a rounded answer. But that would be 27.03 is what I get if I round that. So angle A is about 27.03 degrees. So now I am going to solve for angle B. And I get angle B, all you have to do is say 180 degrees minus, and then we were given 110 minus 27.03, and see what we get. So that's going to be 70 minus 27.03, 42.97. I mean, you may even see that written as 43 if it's a multiple choice problem. That's so close. But technically we have here that B is equal to 42.97 degrees. And again, you may see that written as 43 degrees. You may see this written as 27 degrees. It's just really, really, really close. All right. Now the last problem on the review, same directions. You're given another triangle. All right, so this is a side, side, side triangle. And it doesn't matter how you label. I guess there's a picture that labels this A, this B, and this C. So that means this will be side C, this will be side B, and this will be side A. Alright, so since we don't have any of the angle measures, it's a side, side, side triangle, you know that you are going to have to use the law of cosines. So what I would do is I would use the law of cosines twice and find two of the angle measures, and then use the fact that all three, when added together, have to be 180 degrees to find a third. So let's start out, let's use the same formula we just used. The cosine of angle A is going to be equal to b squared plus c squared minus a squared divided by 2bc. Alright, so I need to plug those numbers in. And good thing, I don't have a lot of decimals or anything, so these all should square pretty nicely, and hopefully I won't have any problems. But that's 4 squared plus 6 squared minus 5 squared over 2 times 4 times 6. Alright, so that's 24 plus 36 minus 25 over. It's going to be 8 times 6 is 48. Alright, so that's going to be 35 over 48. Alright, so that's what the cosine of angle A is equal to. So we need to actually say 35 divided by 48. And now we need to do the inverse cosine of this. Now the up arrow or the second function's already been pushed on this calculator, so you can see inverse cosine there with a little -1. Alright, and so I'm going to round this to 2 decimal places. Well, let's just round it to 1 decimal place, so 43.2. So that angle A is about 43.2 degrees. Now let's solve for angle B. So the cosine of angle B is equal to a squared plus c squared minus b squared divided by 2ac. So that's going to be 5 squared plus 6 squared minus 4 squared divided by 2 times 5 times 6. Okay, so 25 plus 36 minus 16 divided by 2 times 5 times 6 is 60. Alright, and so that's going to be 51 minus 16, no, 61 minus 16. Let me do it in the calculator, don't want to mess up. So 20, sorry about that, 25 minus 36 equals, I need to add, I'm flustered, 25 plus 36 equals minus 16 equals divided by 60, and I should get a decimal, 0.75. So that's the cosine of angle B equals that. So now we want to do inverse cosine again, and that gave us 41.4. So angle B is about 41.4 degrees. Alright, so we've solved for angle A and we've solved for angle B. And so angle C has to be equal to 180 degrees minus 43.2 degrees minus 41.4 degrees. Alright, I'm going to do that in a calculator. So that's 180 degrees minus 43.2 degrees minus 41.4 degrees. So that tells us that angle C must be 95.4 degrees. Now you could use the law of cosines with your A, B, and C lengths and find angle C the same way that you found A and B. If you have enough time and you want to check and make sure, go back and use the formula for angle C and see if you get this, and you should. Alright, good luck on your exam. Have a good day.